So, we've talked about objects in the universe and how we know information about them from the light, but how we know how far are those objects. And many of them are at very, very big distances. And in which units we usually you usually measure distances? What units of measurement for distance do you know? Meters, kilometers, centimeters, but for example, if we take even distance from Sun to Earth, it's not the same all the time because Earth's orbit is not perfectly circular, but it's quite close to it. So average distance from the Sun to Earth is 150 billion meters. It's not very convenient and easy to operate with numbers like that. So first of all, we will be using a lot of scientific notation. Reminding you, this written as a scientific notation, we have only one digit in front of the decimal point, one non-zero digit in front of the decimal point. So it will be 1.5 and times how many steps you move decimal point. 1, 2, 3, 6, 9, 10, 11, 12. So times 10 in the power of 12 meters. Again, still not very convenient to operate with such number. Plus, it is very, very significant thing, the distance from Earth to the Sun. So it was given special name. It was given special name. It's called 1 astronomical unit, or 1 AU. 1 astronomical unit is distance from Earth to Sun. And it's very convenient to measure distances in the solar system using astronomical units, because it all will be distance from Sun to Earth is 1 astronomical unit. Let's say to Jupiter will be few astronomical units and so on. But as soon as we will get further than the solar system, and then astronomical unit becomes again too small for measurements. And so we need to introduce bigger unit of measurement. And such unit of measurement is light year. 1 light year. Even if it's called light year, it's not unit of the time. It is unit of measurement of the distance. 1 light year is the distance that light travels in 1 year. How we can calculate it? Speed of light, so how far light moving in 1 second, is 3 times 10 in the power of 8 meters per second. That's how far light travels in 1 second. Who knows what is the Earth's circumference on the equator? Anybody know what the Earth's circumference? Okay, it's 40,000 kilometers. Earth around the equator is 40,000 kilometers. If you, and 40,000 kilometers is 4 times 10 in the power of 7 meters. How many times light can go around Earth in 1 second? If that's how far light moving in 1 second, how many times light can go around the Earth in 1 second? How we can find it? That's how far light moving in 1 second. This is the Earth's circumference. How we find how many times light can go around the
3 times 10 to the power of 8 divided by 4
Yeah.
times.
Yeah. Yeah, we divide, and if you do, you will get 7.5 times. So light can go around the Earth 7.5 times in 1 second. Now, let's continue to derive what is 1 light year. So that's light travel in 1 second. then how many seconds in 1 hour? Well, guys, how many seconds in how many minutes in 1 hour? 60. How many seconds in 1 minute? 60. How many hours in 1 day?
24.
24.
Yeah, that's it.
Yeah. And how many days in 1 year?
How many days?
365. And if we multiply all of that, we will get the number. We will get 9.46 times 10 in the power 15 meters. So light year, as you can see, is a quite big distance. Light travel in 1 year, very big distance. But still it's not very big units for the space, because even closest star to us, except Sun, is about 4 light years. And many stars are away thousands of the light years. So light coming from those stars, thousands, from some millions of years. So what we see, we don't see what happens at that star now. We see for some stars what happened with those stars millions of years ago, because that's how long it takes light to come to Earth. But there is one more unit of measurement, which is called parsec. But to introduce parsec, we need to now look how we measure big distances. How we can measure distance, for example, to the even nearest star. We cannot go there and just measure the distance. So we need to...
Light. How long it takes the light to?
How we know? How we know when it started from the start? We don't know when, so as soon as we don't know distance, we cannot find how long it came. So, to find distance to the object that we cannot get to, we will be using parallax. What is parallax? So, take your finger, close one eye, and point your finger, let's say, to this end of the board. So, a line, close one eye, and look on this end of the board. So, vertically, keep it vertical. Please, everyone do this. Everyone, please. Everyone, yeah, look, close one. Now, open that eye, close the open eye and open what was closed. You see what happened?
Yeah.
It jumped. Yeah?
That's crazy.
You see, it jumped.
That's crazy.
That's called parallax. Parallax is apparent change in the position of the object when position of the observer changed. Did this end of the board move?
Yeah.
Did it jump? No. It stayed where it was. But you were looking from different positions because your eyes are not at the same place. They have some distance between them. So, when you look from one position, you see it at one place. When you look from another position, you can see, you see it another. And then using trigonometry, we can find distance. So if we look to some object from point 1 and we look from point 2, we can measure the angles. We can measure those angles. Let's say angle theta and angle theta. And we can measure our baseline. We can easily measure distance between our eyes. measuring those two angles and measuring this distance, then using trigonometry, we can find the distance to the object. But our distance between our eyes is pretty small, so we cannot measure too far. So what was taken at this baseline was taken the diameter of the Earth orbit. So if you look, so if this is the Sun, and we have Earth moving around the Sun, and we look to some star, distant star, at one day, and then we, 6 months later, when we will be on the other end of the Sun orbit, so that distance, what will be this baseline? What will be distance?
40, 30, or 20, 30.
2 AU, 2 astronomical units. The radius of the Earth orbit is 1 astronomical unit. So diameter will be 2 AU, 2 astronomical units. And we measure angle from here. And knowing this distance, we can calculate distance to the star using just basic trigonometry, so at all. And if, let's say, we have, this is a star, some star, and this is half, this is the Earth orbit. This is the radius of Earth orbit. So this is 1 astronomical unit. And this is the angle theta. If you know those angles, we can find that angle. If this angle, at which from the star, we can see the radius of Earth orbit, if this angle equal 1 arc second, now, what is 1 arc second? What units of measurement of angles do you know? Degrees. But there are smaller units. 1 degree has 60 minutes in it. 1 degree divided by 60 smaller units, like 1 minute of time divided in 60 seconds, 1 degree, the angle divided in 60 minutes. And 1 minute divided also in 60 seconds. Is 1 degree a big or small angle?
Small.
It's pretty small angle. And 1 arc second is, so 1 degree equal 3,600 arc seconds. Or in mathematics, often they call just seconds, in physics arc seconds. So it is very, 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 very tiny angle. Our eye cannot distinguish such small angle as 1 arc second. The best that the human eye, trained human eye, can distinguish is a 30 arc seconds. It's the best that human eye can do. But technology and technology on the telescopes that are in space, they can do better than that, so we can measure further. And if this angle equal 1 arc second, then this distance from star to Earth called 1 parsec. 1 PC is called parsec. 1 parsec. So 1 parsec is a distance from which radius of Earth orbit will be seen at the angle of 1 arc second. And to do calculations, we can use the formula P equals 1 on D, where P is angle in arc seconds, angle in arc seconds, and D is distance in parsecs. Example, if some star is at the distance of 25 parsecs from us. If some star is at the distance 25 parsecs, at what angle we will see it? Not we will see it, at what angle the Earth, radius of Earth orbit will be seen from that star. P equal 1 on 25 equal 0.04 arc second. So if star is 25 parsecs away, the angle at which the Earth, radius of Earth orbit will be seen as 0.04 arc seconds. Make sense? Let's do opposite. If the angle is 5 arc seconds, what will be the distance to that star? If P equal 1 on D, D will be 1 on P, will be equal 1 divided by 5, equal 0.2 parsecs. And for remaining time today, we will be practicing to convert between units of measurement, between different units of measurement of the distances.